The other important plot in a meta-analysis is a funnel plot. So it's important that you know what one does and that you can interpret the meaning of your funnel plot, as well as thinking about a contoured funnel plot. So a funnel plot tells you about the variability of the individual studies, their standard error, against the mean effect size. So why do you need to care about that? So this gives you some sort of idea as to whether there's any skew on underreporting in the literature. So it's called a funnel plot because as the study size increases, the standard error should approach zero. So it'll come to a point. It's a bit like a pyramid. So it assumes that the plot should be symmetrical. And that means that there should be as many studies that are above the mean as below the mean. So to the left and to the right of the plot. And it also assumes that you've got an even distribution of the variabilities. So this is a good funnel plot. So you see the standard error goes towards zero at the top of this point. So I'm going to imagine it's a bit like a pyramid. So at the top of the pyramid, the standard error goes towards zero, and it gets much larger as you get smaller studies. But what you're expecting to see is a scatter within that funnel. It should be evenly above or below the mean difference. And you don't want to see too many points outside of the funnel itself. So in the case illustrated, there's a symmetrical scatter of points on both sides of the weighted average mean difference. They're equal numbers above and below. Unequal scatter indicates that you've got bias, which might be due to publication bias, but is more likely you've got a small study bias. That small studies, because they've got a high amount of variability, there's a tendency for them to be either over or under published. So if you do a small study and you don't find a significant effect, you don't report it. So it will disappear from all of the studies. Whereas if you do a small study and you find a highly significant effect, you're more likely to report it. So you'll get a preponderance of positive results compared to negative. You also want some scatter evenly throughout the funnel, just not just all clustered at the bottom, which means large standard errors and small sample sizes. A more sophisticated version is the contoured funnel plot. So as well as showing you the funnel itself, you have some contours dependent on the p-value. So this is indicating how strongly you reject the null hypothesis. So in the white area, you can't reject the null hypothesis. In fact, the p-value is greater than 0.1. So there's no significant result in those particular studies to show that there's a difference between the control and the treated group. So in this case, 2 studies are in that region. In the purple region, you're still not significant, but you're approaching significance, and there's one more study excluded there, which is a particularly small study. Then you've got the darker blue region, where you have significance, but the evidence is not very strong, and then you have the light blue region, where all of that is showing a significant difference, and you've got strong evidence. So, as I said, p-values are the contours for rejecting the null hypothesis. The white areas where you can't reject it, light blue is the best possible cases. In this case, there's only 2 studies with no significant difference, which is good evidence that there probably is a significant difference, and those 2 studies only didn't find some because they were too small and what we call underpowered.